So there you go. That was an excerpt from our panel discussion on the digital flow of information in the factory. We cut to that rather quickly. So, Michael, we're going to join straight away now, move over to North Carolina to visit Juki. And we're going to visit Gerry Padnos. We were originally going to go to California. I know that's on your notes, but we're actually going to North Carolina now. So welcome, Gerry.
Yeah, hi, thank you for inviting me to join today. It's my pleasure to be a part of this.
Absolutely. So we've been talking earlier today, Gerry, about the materials management and the flow of materials to the line. It's a critical component of the smart factory environment. Are you going to give us a demonstration today of how Juki works with regards to the flow of materials coming from your storage towers?
Yeah, that's the plan. So we have, as you said, the RS1, and I was listening a little bit earlier when Michael was talking about the criticality of delivering the parts on time, knowing the counts of the components that you're delivering, because if you're off just by a small amount, that can completely mess up your production plans. So we have all this integrated. Our general goal is to automate the factory as much as possible and to eliminate manual systems. So one of those systems that we're going to be talking about today that I'm going to show you is when the production line is running low on components, the ability to automatically request and receive components from the automated storage towers that we provide. Unfortunately, in my demo room, I don't have the ability to show you the robot that would actually deliver it from the storage tower to the production line. But for today, I'll be the robot. You can use your imagination a little bit on that one.
Okay.
But as Michael was saying, quantity is also a critical element, having the correct quantity count. And that's one of the reasons that not only do we have the storage tower that's automated or the delivery robots that are automated, but we also have an integration with X-ray counters so that you can see the number of components accurately and that it's distributed amongst all the systems that you're using. So all the systems know what's going on. So if you're ready, I can get started with the demo.
Yep, take it away.
Okay. There's going to be a little bit of time involved here because as we're running production, I need to create the situation where we're running low on components. So I'm going to run production for a little bit and we can kind of talk in the middle. What you're going to see is just a demo board running here, and the machine's going to just pick in place as it normally would. And then at some point, I've set up one component intentionally, so it's going to become low on the remaining quantity. And with our integration, with our middleware, we can integrate or interface with virtually any major brand of pick-and-place machine. So while I'm showing it on a Juki pick-and-place machine, of course, because that's what I have, our storage towers work with virtually any major brand of pick-and-place. So our software is counting the original number of components on the reel. And then as it's running production, it's updating the number of components remaining. And in our software, we've set a time threshold of when the replacement reel should be requested. In my case, I've set it so when there's 10 minutes of components remaining or less, then it should request a new reel from the storage tower. So depending on how the exact timing goes, I may need to run this board a second time, or it may be kind of towards the end of this board. But for this point, all you're really going to see is the standard pick-and-place operation. I can turn my camera a little bit while we're doing this, and this is our software where you can see the status of all the reels. And eventually what's going to happen is one of the reels over here is going to have a little yellow mark that may be difficult to see. When that happens, it means we've detected a low-level condition. So back to the pick-and-place, we didn't quite finish that board. So I'm sorry, we did finish the board, but we didn't get our low-level warning yet. So I'm going to stick another board in and let it run.
Yeah, this is the essence of lean, because we're creating here, the machine is creating a pull signal. It is that pull signal which is the essential element for lean material management, so that you only deliver the materials as and when exactly they are required. And that is the minimum then waste. in the whole process.
Exactly.
So this is a great illustration of creating that pull signal.
So you said, Gerry, that you're connected to a component counter system. Is that integrated into your tower, or is that a separate standalone device?
It's an integrated X-ray counter, and right now we're working with a couple different manufacturers for the component counting. Again, in my demo room, I don't have the actual counter system set up, nor do I have the robot, but this is our component storage tower. And as soon as we get the low level warning, we should start to see the tower moving. The signal light at the top will change to yellow as it moves and begins to deliver the next reel. So we're still running production. Unfortunately, it's a little bit hard to manually create the situation where you run low on components. So I'm hoping that when we finish this board, we're able to see that.
It's way too efficient, that machine, isn't it?
I know, yeah. I'm hugely impressed how you're managing to be both machine operator and cameraman. Oh,
yeah. Aha. So we received the warning, but the software thinks that there's not another reel available. So let me see if I can find out if I forgot to return the reel to the tower. Meanwhile, I'll run another board.
So the interesting thing about generating the pull signal here is that we have a heads up that the material will run out. So we can continue manufacturing while the material is being sought. So this is a very important part of the timing element of when you get the yellow warning and when you actually stop. And that can be set up depending on the location of the storage tower and any other work that may need to be done to collect that material.
Yeah, absolutely
So
agree.
the storage tower has begun to pull the reel now, and it's now available. I don't know how well you can see the green light on our fast exit drawer down here. This indicates that we have a component ready. And the purpose of the two doors, that we have the drawer on the bottom, if the tower was busy putting away components or pulling a kit, obviously the line should take a priority for, as Michael was saying, to have the lean manufacturing, to deliver it just in time. So we're going to pause the work that's going on in the elevator and extract the reel that we need for the line down at the bottom. At this point, again, I'm going to play human robot, and we would deliver this down to the production line and continue production. But that's basically the process. This allows us to keep the components not only safely stored from a physical safety point of view, because as we all know, if we were to extract all of these reels ahead of time, they bin something, a tote that's placed near the production line so that you have the parts available when you need them. However, those have a habit of disappearing when you need them the most. So that's one issue. But the other, of course, is MSD, that if you have moisture sensitive components, that means you're leaving all those components out for a lot longer than what they really need to be left out.
Yeah, yeah. And I guess
it's really what you don't see here that's important, isn't it? Because you go to a normal factory, let's say, and you will see as much floor space being taken up by materials, all getting dusty and dirty and lost, as you do with actual added value production machines. Here in your demonstration, there's no need for anything other than machines. So the productivity per square meter on your shop floor is the highest it can possibly be. But again, you also have that control of the materials. So it's a great utilization of technology.
Absolutely.
Exactly.
Yeah. And so I'm guessing when you put the component reels to the storage tower, it's going to automatically count what's left on that reel and return these back into inventory.
Right. So there's a couple of good points. For an approximate count, when the pick and place machine is running, through our middleware, we can interface with the pick and place and receive the number of components that have actually been placed on the PCB. But as we all know, in actual production, when you're loading or unloading a reel, you may lose a couple components, or the operator goes and manually advances the feeder or something. And that's where the X-ray counting will give you the true correct count. So once the reel's returned to the storage tower by the robot, then we'll integrate we'll use the integrate X-ray counter. And you can set up a schedule. So you can count at night, you can count at shifts that you're not working. And the storage tower will simply take the reels and put them into the X-ray counter according to the schedule and the type of reel that you set up, and it'll count it. And once it's counted, it'll return it back to its storage location and update the quantity remaining.
Right. Excellent, excellent.
That's
Well,
pretty cool.
thank you. Yeah. Well, thank you very much for giving us a demonstration, Gerry. And it's been very helpful to see. I think, as Michael says, that the key element here is that pull signal, getting that alarm or that alert ahead of time. You know, I seem to recall a time going to watch the launch of a new pick and place machine with a very efficient company, and they had a new head, and it basically we're in a real factory situation, and the machine started placing the components, and it was so fast it literally ran out of components in about 3 minutes, and the operator had to go away to the store to get more components to put back on the machine, and she put them back on, and it went for another 3 or 4 minutes. I mean, I'm exaggerating, of course, but I mean, what I'm saying here is that getting that alert ahead of time is critical to keeping your machine uptime and keeping the manufacturing running. So
Right.
Thank you, Gerry. And we hope you're having a good show, and we hope to see you in real life sometime sooner.
That would be good. The weather here is great this week, but should be in San Diego. So hopefully we'll see you guys next year in San Diego. Thank you, Michael, and thank you, Trevor, for inviting me to participate in this.
Okay, thank you very much. Nice to see you.
How low can you go?
Low temperature solders enable manufacturers to lower reflow profiles, improve quality, and reduce operating costs. Abstracts are invited from leading researchers, industrialists, chemists, and metallurgists. LTS 2021, June 16th. Click below for more details and to submit your abstract.